Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shen, coming to you live from Walker Grant Middle School. In this video, we're going to be working on some error analysis. And so what I'm going to do in this problem is I'm going to read through it, see what they messed up on, and then what I'm going to do is I'm going to go ahead and see what the correct answer is. So it says, describe and correct the following, let's try it again. Describe and correct the error in finding the probability. And it says you have 5 pairs of white socks and 10 pairs of black socks in a drawer. You randomly choose 2 pairs. What is the probability that both pairs are black? And so again, this answer that they give is incorrect, and so we need to find out what is wrong about it. So they have the probability of the compound event black and black, so that's 2 pairs of socks being both black. So then it has probability of finding black times the probability of finding black is 10 over 15 times 10 over 15, which they reduced to 2 over 3 times 2 over 3, which is 4 over 9. So again, this is incorrect, and so let's see what is going to be the mistake. And so what I'm going to do first is I'm going to kind of draw out our sample space. And so again, anytime you want to do that, so I'm going to say sample space. And so I'm going to draw out that drawer of socks. So I have how many white socks? I have 1, 2, 3, 4, 5 pairs of white socks. And then I have 10 pairs of black socks. So I can actually do a little bit darker. So do 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So all together we have 15 total. So we have 15 total pairs of socks. So 15 total. And so what I want to do first is I want to say, well, what's the probability? What is the probability of picking a black sock? Well, how many black pairs of socks are there? There is 10, and so I'd have 10 on top and 15 in the denominator because that's how many total I have. Again, yes, you can simplify this. So I'm going to divide by 5 over 5, and so this is going to be equal to 2 over 3. And so now the key part though is when you are packing or wearing a pair of socks, are you going to put those back? I am not. So you have to make sure that you take those out. So I'm going to say that I have to take 1 out. So I have to take 1 pair of black out. And so that means that 14 remain. And this is where the mistake is at, because they said that there are still 15 remaining. However, this is not the case. So we're going to say now our probability of picking, let me write that a little bit better. The probability P of picking a black sock after, again, that keyword after means that it is a dependent event. So keyword after, we picked a black already out. How many black socks remain? Well, since we took 1 out, there's going to be only 9 left. So there's only going to be 9 left. And there's of the total 14. Of that total 14. So now again, the compound probability is going to be these 2 fractions multiplied together. So I'm going to say the probability of picking a black sock and picking another black pair of socks after we already picked some out is going to be like this. We're going to have 2/3 times 9 over 14. Again, I want to use my Desmos calculator, multiply in the numerators first. And so I say 2 times 9 is 18. And then I have 3 times 14 is going to be 42. So I have 18 over 42. Again, I can simplify this since these are both divisible by 6. I can simplify it like that, so I'm going to divide by 6, divided by 6, and so I have 3 over 7 as my answer. Again, I can also write that as a decimal. So if I have 3/7 as a decimal, I can say it's about, let's say it's about 0.43, which is 43%. And so when you are trying to figure out what the conclusion is, you'll need to make sure that you're saying that it is a dependent event, meaning it does change the denominator. So what they did, their mistake is they didn't change their denominator in their second event. Again, make sure you are seeing and using that Desmos calculator, and as always, super slam that subscribe button.